3-8. And this is applying what we've been learning in the previous lessons dealing with equations and inequalities. There's equations and inequalities. And some of you have already asked this before. Mr. A, are we going to do word problems? Here's your answer. 5 minutes. Okay, so make sure that you pay attention because this will be on the test. So don't feel that this is going to be unexpected. I put a couple word problems on there. It's going to come from this lesson, and I hope you guys are ready for that. Okay, so who wants to read for me on page 156, an application on a world record dealing with pancakes? It sounds messy. Go ahead.
Me?
Yes, Murphy.
What takes 400 pounds of butter, 500 volunteers, and 3 boxer tables? The world's biggest breakfast. Springfield, Massachusetts, and Battle Creek, Michigan complete every year to serve the world's largest pancake breakfast. 66,344 people were served 132,688 pancakes in 2 hours in Springfield.
Whoa.
Each person was served the same number of pancakes. How many pancakes were served to each person?
Okay, that's a big breakfast. And this was many years ago, and they compete every year. So you think they've upped that number in the years? Yeah, so this is like 20 years ago, it may be more. Okay, the 2 cities, Springfield, Massachusetts, and Battle Creek, Michigan. Battle Creek. Do you guys know that you partake of Battle Creek's products many times? Maybe a week, maybe a month. Okay, does anyone know Kellogg's?
Yeah. Yes.
Like they have cereal, Pop-Tarts, pancake mix, right? How many of you have any Kellogg's product? They have like cereal bars, oatmeal, blah, blah. Okay, that Kellogg's is located in Battle Creek, Michigan. That's where their main headquarters are. So the reason they're talking about breakfast is because Battle Creek has a lot to do with breakfast, and they also make pancake mix, and they battle with Springfield, Massachusetts. Why Springfield? I don't know about Springfield, but maybe they have breakfast there a lot too. All right, man, those are some big numbers. What we're going to do in this lesson is we're going to be able to take problems that are shorter than that. Okay, they're not going to be that long, but we're going to take that info, and what are they asking me for in this problem at the very end? Each person was served the same number of pancakes. What's the question? Yes, ma'am?
How many were served to each person? So probably.
Okay, so you're already thinking what to do. All right, how many pancakes were served to each person? All right, this is what I want you to do. Some of these problems will be very easy. You'll be like, yes, I got it. And some of them will be a little bit difficult. I want to train you for the difficult ones. And if you train this way, you can get easy and the hard ones. All right, so how many pancakes were served at that competition? Nick?
32,688.
All right, 132,688 pancakes. All right, so that's a lot of pancakes. And then how many people were served at that competition? Jake?
66,300.
All right, 66,344. Now, some of you are saying, oh, I already see it. But I want you to work it out as if you don't know because, again, not everyone is going to know the answer right away. Okay, so that's what I know about this this problem. Do I really need to know what cities competed? No. That just gives you more info to kind of understand what's going on, but it's not necessary to solve the problem. So we eliminate that. Did they say anything about how many pancakes people ate? They gave you one piece of info that's critical. Yes, sir. They all ate the same. Man, they ate a lot. 132,688, right? Okay, we'll see. All right, they all ate a lot. Do we know how many they ate?
Too big.
No, we don't know. So we're going to say that they ate X number of pancakes. Okay? We don't know. That's how many pancakes. So they're going to ask you to define a variable. You just pick X. If you would have listened before, I would have told you this problem you can maybe get quickly, but not all of them are going to be that simple. So let's go through a process. So X, is going to equal the number of pancakes per person. Per person. Okay, and we don't know it. Again, yes, you got it. Congratulations. Show it to me algebraically. That's where I'm impressed. Okay, so how many pancakes did everyone eat all together?
132,680.
Okay. How many people ate?
66,000.
How many did they each eat? Don't know. But don't I know that however many they ate times the number of people would equal the total?
Yes.
Like, do I know that? Is that really true?
Yes.
Okay. So, mathematically and especially algebraically, I have this equation right here. What's happening to x? It's being multiplied by this number, so what do you do to both sides? Divide by that same number, 66,344. 66,344. Now, just like with the little numbers, what happens to this number over itself? What does that become? 1 times x, which is just x. Okay, so that's what happened. These got canceled out. Okay, and then what's 132,688 divided by 66,344? Oh, that's where you got the 2. Now, is 2 my answer?
No. 2 pancakes per person.
Very nice. 2 pancakes per person. Yeah, just be careful with your units. 2 pancakes per person. No. Yes, ma'am?
How did y'all figure out 1,300 or 132,688 divided by 66,344?
Yeah, no. That's not enough because they give me the answer. What you had to do is divide it, and you know what's nice? That goes into this number twice exactly. And you could guess. Maybe you're like, I think it goes into it 3. So you do 3 times that. It's too high. Okay, 2. You multiply it by 2, and you're like, oh, that gets me exactly how many times. So you just have to work it out, and you'll get it. Thankfully, I'm not going to give you those big numbers. How about that? And so you'll be able to work it out hopefully, very well. Okay, so that's how many people or pancakes per person. Now, if I didn't put a unit, would that change the answer? What do you think?
Yeah.
Because 2 meant a lot of things. In fact, if I just put the answer 2, okay, which is not correct. Oh, I get it. 2 means the number of cities that competed. No. 2 means that's the time of day that they had the competition. 2 a.m. No, that's too early. 2 p.m. No. Wait, is that a brunch? Wait, okay. 2. Where did they get that 2 from? You gotta tell me what it means. 2. Come on, guys, help me out. Per person. So, did everyone eat a ton? No, they ate 2 pancakes. 2 pancakes is like an average serving of I don't even know, but not a lot, not a little, just 2 pancakes. Okay, let's look at example number 1. Can someone read that for me, please? Special Olympics. This is impressive, and I'll give you some tie-in. Chelsea, let's have you read example 1.
Special Olympics athlete Andy
Leonard
is one of the few American athletes who can lift up to 4 times his own body weight. The most weight he has lifted is 385 pounds. What is his body weight? Round to the nearest whole number.
Okay. Very, very impressive. Okay. If you read through that and hopefully paid attention, this is what it's saying. That this athlete can lift up to 4 times his own body weight. Okay? So we're going to find out what his body weight is in just a moment. But I want you to think of an ant. Do you guys know what an ant can lift compared to its body weight? 10 times. 10 times is that number. All right. So that's pretty impressive. Huh. Let me give you a little illustration how that works. All right. I weigh 200 pounds. So if I were an ant, how many pounds would I be able to lift? 2,000. That is equal to 1 ton. So if I were an ant, I should be able to carry a ton on this back. like literally a ton. 1 ton. Which, if you're like, what does that even mean? Basically a car on my back. Just carry a car. And just carry it for a very long distance, by the way. Okay, let me give you another comparison. A flea. Fleas jump far. They jump far, like even when we don't have pets, but fleas, I remember those with other pets that I've seen, and you can actually sometimes see them if they're bad enough, jumping and making those big leaps. You know what's cool about fleas? If I were a flea, I could jump a mile in 8 jumps. 8 of these jumps would get me a mile if you were comparing a flea to me. That's pretty impressive, isn't it?
Yeah.
Okay, so I think of it, okay, the ant can carry a lot. The flea can jump really far. Think of it like this. The ant is very small. The flea is maybe a bit smaller, depending on the ant and the flea. Oh, I hope a flea's not that big. But anyway, you get those two. They're very small. And you know what they say in the science community? The smaller you are, the more insignificant you are. But I think to myself, 10 times its own weight, and this thing was evolved out of something? No way, guys. I don't believe it for one moment. In fact, I know that there was somebody who created the flea and the ants and made them that unique and that strong or powerful to be able to do what they do. That's awesome. And do you guys know that there are smaller things that are so complex that you could take forever just to study that little small thing? Because God didn't make things insignificant. He made everything very complex. So when I think of something evolving, I'm thinking to myself, is that single-celled organism like an amoeba? Is it really that basic? No. Guys, the DNA structure of a single-celled organism is super complex. And that's something that doesn't happen by accident. I'm sorry. I can't believe it. That takes a lot of faith to look at a genetic code of some animal and to say that they came from nothing. I'm like, whoa, that's pretty amazing. That's amazing. Yes, sir.
So with your hands, you demonstrate how far a flea jumps?
Yeah, so like if the flea was on here, I think they're going, I think they said 18 inches. So they're doing like something like that. So I think you can. Not 18 inches high, sorry, 18 inches far. I think you can. I'm guessing, but like again, they're like this small. You see how small I'm going? Yeah. And then our feet are many more times that big. But yeah, it'd be like, actually, you know what? I thought it was maybe like 3 feet, so it's kind of like that, like a yard. And so like if I were doing that in my life, I'd be jumping 8 times to get to a mile, which is like cross country, we'd be champs, right? Just jump. Anyway, so that's very impressive. And then with that ant and other bugs that can withstand the pressure of somebody like stepping on them, oh my goodness, these things are not accidental. These are actually things that were created into them. Okay, but anyway, let's look at example 1 again. This is a human who could do something that's pretty impressive. So Andy Leonard can lift up to 4 times his own weight. That's what I know here. Up to 4 times his weight. That's the key I want to get. So I'm going to have to get that cut off. Up to 4 times his own weight. Okay, do we know what his weight is?
Yes.
No, we don't know what his weight is. What do you think I should use for his weight? Just like a variable. If you want to say W, which stands for weight, go ahead. If you want to use X, fine. Just use something that makes sense. Okay, 4 times his weight is going to be related to, what's that number that he can lift up to? 385. Now, do you think this is an equation or an inequality? Okay, I heard both. Okay. Why is it an equation or why is it an inequality? So somebody tell me the reason. I don't want to, because I think it's because the book says so. Yeah, great. You can read. That's amazing. But why is it an inequality or an equation? Anybody? Yep, Annie?
I think it's an equation.
Okay.
Inequalities, they like compare things, and we're not like comparing how much he can.
Okay, I like that reasoning. Inequalities tend to compare. Yep, Josh?
I think it's an inequality.
Okay, he thinks the opposite?
Yeah.
Okay, why?
Because, Like he's carrying more than his body weight, so you can't have an equal sign to compare. So it'd probably be like greater than or equal to sign.
Less than or equal to.
So yeah, I think it's an inequality. Which one is it going to be?
I think both.
You can't. I don't think.
I like that. Less than or equal to. All right. What's the top amount of weight he can carry?
385 pounds.
Okay. So can he carry 384 pounds?
Yeah.
Can he carry 380 pounds?
Yes.
Can he go 385 pounds? Can he go 386? No, right? So he can go up to 385, nothing above that. So he can go all the way up there, which means it's an inequality less than or equal to 385. So that's what we're saying there. Yes, ma'am?
I'm confused how you know how to make it an inequality or like.
And this is, on the problems I'll give you, they're simple. They're they're one sentence long problems. So they're not going to be super complex to talk about all these scenarios. But I want to tell you this right now. The way I know it is through the words, and that's through grammar. That's how you're going to know it. You guys remember linking verbs?
Yes, we do.
If you find a linking verb, it's going to probably be an equation. If you have another type of verb, it's probably not going to be an inequality. That's how awesome. Why do you think I love language? Because it relates to math. Why do you think I love math? Because it relates to everything else. And God, yes, it all relates back to Him. It has to. Because it's all logical, orderly, complex. Sir. So I'll help you out with what words are going to be. Yep.
Did he say it would probably be?
Probably, yes, because there are some where they're going to do a little bit tricky, but I'll help you find those.
Okay.
Yep. Yes, ma'am?
How much can you lift?
Ooh, good question. My top weight on a squat, so that's doing this with the bar, I'm going 195. So that's almost my body weight. So this dude is way more impressive than Mr. A. Sorry?
Too good with me. Not count.
Yes, please. I maybe twice a year or something. Anyway. Yeah, but the thing is, listen, we're going to work this problem out, and maybe you said, you know what, I think it's greater than or equal to, or I think it's less than or equal to. So we're going to work this problem out and find out what our answer is going to look like. All right, what do you do to solve for this inequality? Yep. Divide both sides by 4. You guys are doing well with this. This is review. I hope you get it. I divided by 4. So what do I do with that inequality?
Flip it or flip it.
No, we don't. Does it have negative?
Cool. I don't flip it. I was trying to throw you off. When do I flip it?
Negative. Both negative signs.
If you divide it by a negative. We didn't do that. We keep it the same. All right, 385 divided by 4. Okay, what did the problem say to do? Round to the nearest whole number. So I don't have to go all the way because it goes into the hundreds. So 4 goes into 38. 9 times, that's 36. 2, 5. 4 goes into 25. 6 times, 24. 1. I got to start bringing my decimal point out. 4 goes into 10 twice, and it goes out. It keeps going one more decimal place, sorry. But I have to round it to the nearest whole number. So I look at this number right here. This is the ones place. And then I look, does the 2 make it go up or stay the same? So this rounds to 96. But what's my answer? Is it 96?
No.
96 pounds. Whoa. This dude weighs 96 pounds, and he's lifting 385 pounds.
I weigh more than that. That's crazy.
Yeah, and he's oh my, that's hard. Okay, I can't do that. If you work this problem out and you get something out, let's say you multiplied both sides by 4, and you get this like 1440 something. Yeah, I don't know how old he is, but this dude, it looks like his head's gonna explode. But anyway, I get an answer and I get something like 1,200 whatever pounds. I'm thinking, wait, a person weighs over 1,000 pounds? No, that would be pretty amazing. I'm thinking Goliath maybe, but even then, no, not gonna happen. But then It's not very impressive if a 1,200-pound person, which is huge. Okay, I'm trying to like pretend he's lifting 385 pounds, a quarter of his weight. I mean, that's cool, but it's not that much. Like if I'm saying, you know how you asked how much I can, if I'm lifting up 50 pounds, and you know, that's not impressive. You know what that actually is? It's the bar with 5-pound weights, or 2.5 pounds on it. That's not impressive. Okay, yes. But I can make it look impressive.
If you were doing like X and then less than 96, and you left it like that and just add pounds, would it still be?
Yep. Like that?
Yeah.
Yes.
That would be
Speaking of homework, here's your homework.
That's all we do?
You want more? Okay. All right, listen carefully, guys. Listen. Use your ears. Put your listening ears on. Click, click. I love that at the museum with the little guys. Click, click. Put your seeing eyes on. Click, click. Zip. Zip. Throw the key away. And like for some reason, my son suddenly becomes attentive. So it's amazing. I just got to do that every day. Memorize it. Click, 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 click. Zip. And he'll get it. All right. I'm going to put your homework on the board, and I'm going to help you through these problems. Because I know word problems are not that easy. All right. So your homework is 8 through 13. Hold on. Don't get too excited. And 29 through 31.